All right, so again, good morning and welcome to today's webinar Wednesday. My name is Gabe Crisologo. I'm an applications engineer here at Hawkwood Systems based out of our Mountain View office, and we're going to be covering sheet metal design in SOLIDWORKS. Over the next about 45 minutes here, we're going to be covering sheet metal topics here. All right, we're going to start with the introduction to sheet metal parts, kind of talk about what sheet metal parts are in SOLIDWORKS and kind of how it works, and then show you with a live demonstration there to create a sheet metal part in context of an assembly using the top-down modeling approach. And also show, if we have time, a technique that you can use to convert solid bodies into sheet metal parts to create kind of an enclosure there, or some type of guard for any assemblies and stuff. So first, what are sheet metal parts? So sheet metal parts in SOLIDWORKS are created with specific features, which I'll show you here, right? And specifically, how it works is it's uniform thin-walled parts. It has bends at the corners, and they can be flattened. You can create formed sheet metal parts as well, but the flat pattern may or may not be as accurate as you hope. So again, pretty much anything that you can make with a break. So some of the unique sheet metal items that you'll see in your feature tree are listed right here with a kind of an image right there as well. You'll have a sheet metal folder which controls pretty much the default parameters for the entire sheet metal part. Right. So sheet metal environment in SOLIDWORKS works as the multi-body part environment here, and under that sheet metal folder, you will see the individual sheet metal bodies there as a list, and if you're using any gauge tables, it'll show there as well. The base flange feature here, you can see that it's going to control the specific parameters for that specific feature, such as the depth of the extrusions and any sub features for like the associated bends. And this will make more sense as I go through this part creation here, and I'll go ahead and point all these out. You'll also get a flat pattern folder at the very bottom of your feature tree, and you'll see how that works as well. Okay, so without further ado, let's go ahead and jump into SOLIDWORKS here. And so here we have a satellite receiver. This is what we are going to be working towards right here, specifically this part right here. It's the cover for that satellite receiver. So you can see a bunch of different features on this part. It might look a little complex, but working with sheet metal in SOLIDWORKS is very easy to do, right? And the tools are pretty intuitive and very easy to see what each of those features do, so you can kind of learn them on the fly as well, right? So we're going to be using a few of the sheet metal features. You can see our sheet metal tab here. If you don't see the sheet metal tab in part mode, you can right click anywhere on those tabs in the command manager, and you can activate this sheet metal tab here, and it'll bring up all your sheet metal tools in the command manager. All right, so we're going to be using a few of these, of course, starting with a base flange, miter flange, edge flange. We'll also be using the hem as well, along with some forming tools that we have, and some design library features that we've saved for reuse here as well. Okay, so just like the PowerPoint earlier, here's those components right here in the feature tree, right? So you'll have your cut list instead of solid bodies, right? You're working with sheet metal. And if you had multiple sheet metal bodies here, again, I mentioned it's the multi-body part environment, it would all show listed here in the feature tree. Right. First base flange feature, and also the flat pattern here as well. So if I expand that, you'll see each of these bends here for this specific body, and the flat pattern right now is grayed out because it's not in its flattened state. So you have this flatten button here as well that you can go ahead and click, and it should flatten here. There we go. So you'll see that it flattened here pretty nicely. It pretty much unsuppresses that feature right there in the tree. You can see some of the bend lines, and you can control how you want this to show when you edit this feature for that flat pattern, right? What you want to see, the bend lines, bounding box, Now, one thing to note is when you flatten sheet metal pieces, when you're doing the forming tools, the forming tool or the formed features do not flatten, right? So that's kind of a brief overview of the interface here when working with sheet metal parts. So let's go ahead and create that cover. So I'll go ahead and close this out here. And we'll go ahead and get started with a satellite receiver. All right, so right now you can see that we are working in the assembly environment. Got my assembly tab here. We can leverage display states as well. So this has a display state to just show, no PCB, and you can just see that base of our part here. What we're going to be creating is the top part of this enclosure, right? And we're going to do that doing top-down modeling. So what that means is we're creating a part within the assembly, and we're going to leverage the existing geometry here to create some external references as well. So I'll kind of point out these things as we go through. Right, so right here is this enclosure cover. We're going to go ahead and edit this part in context. Now, if I expand this here, you'll see that there are no features here for this part. So this is pretty much just a blank part in the assembly that you can create. Right. Also, it highlights it in blue right here, letting you know that you are editing specifically this specific part that you said edit part or edit component. And you can see here at the very top that we have our features tab and all our other part features here. Without doing that, if you don't do the edit part mode, you have the assembly tools here. Okay, so a little bit of background there. So we'll go ahead and again say edit part. You'll see the features tab. There's your sheet metal tools here. Okay. So the first thing that we're going to do is start by sketching on this back face here. Right. So I'm going to go ahead and start a new sketch. And I use mouse gestures pretty heavily here. So if you're not familiar with mouse gestures, it's one of my favorite shortcuts in SOLIDWORKS. So if you hold down the right mouse button and kind of very subtly move your mouse, you'll see that this gesture wheel pops up where your cursor is. And to activate any of these tools, what you can do is just go ahead and swipe in the direction of what you want to use. And it is context sensitive. So if you are in sketch mode like I am here, you'll have sketch tools, top level part, assembly and drawing. You can customize these as well. I'll just go ahead and swipe there and activate the line tool. And I'm just going to go ahead and sketch this line in the middle. That's going to be my center line pretty much. Going to leverage some symmetry here. Then sketch this line across, down, and horizontal. Okay, so since this is the center line, I'm just going to go ahead and select that and turn it to a construction line. Now, pretty much what these sketch entities are going to be, it's going to be my sheet metal material here, right? So I'm going to go ahead and dimension these here, and give it a gap for, say, 1 millimeter offset there from the edges. And then this one here we'll make 30. And then this, we can go ahead and snap it to this edge there. All right, so that's going to be the first part of our sheet metal cover here for the enclosure, right, the top part of the enclosure. And what we're going to do now is, if I rotate this over, one second, let me make sure that everyone can see. Okay, yep, if I rotate this over here, you'll see these faces like that. So this is going to allow the top cover to go ahead and snap to that. So if I want to leverage that and create that shape in my sheet metal cover, I can go ahead and right click this edge here and say select tangency. It's going to go ahead and select all those tangent edges there of that bottom kind of groove right there. Right? And I'm going to use this tool called convert entities to project that onto my sketch plane, and it becomes part of my sketch there. Now what I'm going to do is just go ahead and use my power trim tool to get rid of that segment. And that's going to be the a sketch of our profile that we're going to use for our first sheet metal feature here, and that's going to be our base flange tab. So when I select this tool, you can see a preview. It pretty much works like a thin feature with a regular base extrude, right? So it's like a thin feature wherever your solid sketch geometry is. It gives it a specific thickness based off the value that you choose here. and bend radius values here, right? So you can go ahead and specify a value, key that in here, reverse direction. You can also go up to vertex, which is what we'll do, and we'll go to this back vertex here like that, okay? So instead of keying in a value for the thickness of my sheet metal here, right, and then keying a bend radius value as well, you can use this gauge table. And there's a list of built-in gauge tables here that comes out of the box in SOLIDWORKS. I have a custom one made here as well. So say common steel. Now all this is, if you want to see what those are or make your own, I'll show you in just a few seconds here. It's pretty much an Excel spreadsheet that controls these drop-down menus. So a list of gauges and their descriptions. So we'll go ahead and choose 1 millimeter here, right? And for each of these gauge values, you'll have a list of acceptable bend radius values here as well. So you can see here bend radius values. We'll go ahead and choose 0.5 millimeters, and also any K factor values. And you can go ahead and key in the different types of relief if you want: rectangular, tear, all-brown, and the relief ratio here based off of the thickness of your geometry that you have set here. Right. So we'll go ahead and click OK. One thing also to point out is where your material is, right? When you create your sketch geometry and then you turn it into a base flange feature, it's going to put the material, that 1 millimeter thickness, either on the outside or inside of your sketch. Sorry, reverse direction there. Right, so that's one thing you want to just pay attention to, be aware of where it's creating that geometry. So if you're creating your sketch for overall dimensions, definitely want to put it on the inside, or say you're trying to create a clearance for something, go ahead and hit that button to make sure that your material is on the proper side of where you want it to be. And so we'll go ahead and click OK here. And that's the first part of our enclosure cover. If I zoom in here, right, since we sketched on this back face, you can see that we have some overlapping geometry here. So I'll just go ahead and create a sketch on this bottom corner. I'm just going to create a rectangle here to sketch a cutout to give that some clearance there. We'll make this about 15. Right, so when you go to your features tab and to do an extruded cut, when you do extruded cut features with sheet metal, you have the same end conditions here, right? So blind, through wall, up to next, so on and so forth. But you'll also see this link to thickness, which is neat. So link to thickness, what that does is when you check this box, it pretty much detects how thick your material is, and that's the depth it'll go. So it's kind of like an up to next based off how thick your material is. Now this won't work because we have that shape right there. So we'll just go ahead and uncheck that. I wanted to point that out because it's very useful. But in this case, we're going to go ahead and just key in a value of 4 to make sure we clear that indentation right there. And we'll say OK. And there we go. All right. So moving along here, I'm going to go ahead and rotate our assembly over to the opposite side. What we're going to do now is create a base, a miter flange here that's going to go up vertically here and then across over here as well. So when you create these miter flanges, it requires a sketch, right? So you're pretty much sketching the profile. We're going to have 2 steps here. It's going to come across like this, then outwards, and then it's pretty much going to sweep along these edges like so. All right, so we're going to go in here, miter flange tool. I'm going to select this edge right there. And if you're not familiar with what that does, you can see that it pretty much created a sketch on this new plane using this edge and this point as a reference, and it's pretty much creating a sketch plane. You can see the sketch origin right there. Right, so if I kind of rotate this here, right, what I'm going to do is sketch my profile and do this here like that, right? So when I'm snapping to these points, right, what that's doing is pretty much creating these external references for this specific feature to the geometry that I'm snapping to. So the benefit of doing that is in the assembly, if these features, for example, the bottom part of this enclosure base, if that gets larger and this, gets wider here, I'll show you this later, right? This gets overall wider like that. These references to that geometry will enable this top enclosure to pretty much resize with that part as well. Okay, so I'll go ahead and point that out later. So here we can go ahead and do the miter flange now, okay? And that's pretty much what it's doing. I'm sketching that miter flange profile there, and it's going to travel along that flange. Now, when you create the miter flange, you have a bunch of different options here as well. Where do you want the material? Right? Material outside, material inside. We're going to go ahead and say material outside. And you can use this button right here to propagate along the tangent edges here, or you can just go ahead and select this one here. I'll go ahead and do the propagate to show you what that does. It just propagates all the way along like that. And that's what the miter flange does. Again, what we do is sketch the profile that you want your flange to look like here. And then it creates that there, right? So you have some additional options. Notice how it automatically miters the corners. You can go ahead and change the gap in those corners as well by modifying this value. And you can also control the start and end offsets here. So the start would be right here, the end would be over here. So if I wanted to offset that up a distance of 4 millimeters, we can go ahead and key in that value there, and we'll say that's good. We'll say okay, and zoom out there, and there is our miter flange. The next tool I'm going to use now is the edge flange, right? Very easy to use this tool here, edge flange, and I'm going to go ahead and create two flanges that come inwards here as well. Right now, I could have sketched this as well in the original sketch by sketching across, down, and across one more time, but again, showing you more tools that you can use here. So edge flange, all I need to do is select the edge. Now, it doesn't really matter if I choose this edge here or this edge. There is a difference though. If I choose this edge here, that's going to be the direction of the bend where the material is going to go. Now, the reason why I said it doesn't matter is because you can move your cursor in whichever direction you want to go ahead and create that edge flange there. Right? So we'll just go ahead and click that there. And then again, we'll just go ahead and key in the value here for this edge flange. Yep, 12 is fine. And what you want to pay attention to is where your material is, right? Material outside, material inside. What that does, if I rotate here, right, for these edge flanges, it's pretty much where the bend starts and where it's going to put the material, right? So material inside, it's going to be flush with the edge that you selected there. Material outside, okay, and start the bend outside as well. So again, whenever you're creating these flanges or working with sheet metal, you always kind of just want to be aware of where your material is, whether it's inside, outside, where you want to be. Okay, so we'll go ahead and hit the green check. And there is the edge flange. Right, if you ever wanted to go back in there and edit those, even though they're sheet metal features, you can expand them as well, and you'll see the sketch geometry for each of these as well. So if you, I'll show an example of this later. If you know that you don't want it to be this shape here, or maybe you wanted to sketch some tabs here in that same flange, you can go in here and edit that specific sketch. Then you can go ahead and just add some sketch geometry here, trim that on the inside, exit the sketch, and then you'll have your tab created very easily, just like that there, right? So that's how you can customize the shape of your flanges. It's not always going to be just rectangular like that. All right, so we have the base of our enclosure cover, right? That's what we're going to be working with there. I can go ahead and mirror this over now. So if I go to my features tab, mirror, we'll choose the end face here, and we'll go ahead and do bodies to mirror. So this is a solid body, on its own. So that prevents me from having to click all those features, right? Plus, I think it is a requirement when you do a mirror of a sheet metal part that you're doing, you have to do the mirrored bodies. Right, so go ahead and click OK. And there is our sheet metal part. All right, before we show the size changes, I mentioned showing that specific in context modeling with the references with this top part changing as well if this bottom changes. Let me go ahead and rotate this here and do one more tab right here. Right, so we're going to create an edge flange that fits right there. You can screw this in, so we want to have a hole right there as well. So we'll go into our edge flange tool one more time. We'll go down like so. Hey, now I showed editing the sketch after we create it. You can also edit it right here. And if you have multiple ones, you can choose which edge that you are editing, right? So if we go to edit the flange profile, pretty much puts you in sketch mode. So I can go ahead and drag these here. It's pretty much using a convert entity. So even though it's black and a black endpoint here, you can still drag those off like so. And we are going to add some relations here to make sure we have this width of this little flange exactly where we want it. We can also use the convert entities and grab this hole there. Right. So we're pretty much creating that tab here. We can go ahead and give this a dimension and make that 16. Right. So when we click on back here, we can go ahead and go back to our flange position. We want this to be on the inside here. Now you can see with the material inside, when I zoom in, it's still not going to be where we want it. We want it to be a little bit more offset inward. So you can check this box to offset it, key in an offset value like that. And then you can also reverse the direction that you're offsetting it in. So go ahead and click OK here. And you'll see that it's exactly where we want it within this little cutout there, with the holes aligned exactly where they need to be also. Okay. All right, so now we can go ahead and get back to the top level assembly. Right, so when I click this button here, we're going to exit the edit component mode. You'll see that the enclosure cover here in the feature tree is no longer blue, so that lets you know that you're back in the top level assembly. You also have the assembly tab here. Right. So what we're going to test now is the references to all the geometry that we did here, right? So remember when we, excuse me, when we first created the sketch for this top cover, we did 1 millimeter offset from the edge of the bottom as well, right? So if this bottom changes, there's a different configuration here, so I can select that component. I'm just going to go to the large configuration here, click OK. This is where you cross your fingers and hope that you did everything properly, and your top cover should update as well for that 1 millimeter offset off those edges there. So you can see how in context modeling and creating those external references can help you create these here. Now, of course, there's some pros and cons to doing that method with your designs, depending on if you want that to update or not, but that's a topic for another day. So we'll just switch back to our default, click OK, and there we go. All right, so I'm going to open up this specific part now on its own, and we're going to work with this here, right? So when you're working with your sheet metal parts, there's going to be a lot of times where you want to use some forming tools to create, louvers, lances, or some indents on your design. So we'll go to our design library. SOLIDWORKS' design library has some built-in forming tools here, so you can see that there's some bosses, right, little dimples, stuff like that. I have some specific ones created for this part. So we're going to use this indented grip here. Now, how this works is you want to make sure that whatever custom folder that you have with these forming tools in there is marked as a forming tools folder. The same with your default one here as well. When you right click on it, forming tools folder, that way SOLIDWORKS knows that when you drag in this specific part into this part, it's going to use that as a forming tool. So you can see here when I drag it onto this face and drop it, it's going to show you the preview of where that forming tool is going to be, right? If it's when you drop it on that face, it's going to be using that tool from that side. If you want to flip the tool, it'll switch to that direction there, right? So if we set this to 0 to rotate it, we can do that. Switch to the position tab, and it works very similar to the whole wizard, where you are pretty much just dimensioning that sketch point here that drives the center of that forming tool. So we'll go ahead and dimension that here, and we'll say that's 25 from the bottom. Once that's placed where you want it, go ahead and hit the green check, and there is our first formed feature using that forming tool. All right, so if I rotate this part over here, on this backside here, when we first created this part with that initial sketch, we had that 1 millimeter offset, right? So we're going to fill in that gap with a hem. So we'll go to our sheet metal tool here. We'll grab this hem tool, and we'll do a hem on these four edges here. Now you can see different types of hem types: rolled, teardrop, open, and closed hems. Material inside, material outside. So let's go ahead and select these 4, and you can kind of see how this tool works. It'll start to take shape. Right, so that's material outside with an open hem. You have different options for the length of that hem and also that gap. Right, so if you wanted to decrease that gap, for example, we'll say 5, you can go ahead and do that, and you can see how that takes shape, right? So what we're going to be doing is just going to go ahead and do a closed hem here, and we'll set the distance to, let's make that 15, right? And bend outside, closed, there we go. All right, so that's going to fill in the gap, also give this specific part some strength right there in those regions with that hem. We'll go ahead and click OK. And there we go. All right, so the next thing we're going to do here is use the forming tools again to create some locking tabs. And here it is. All right, so when I drag this onto this face, right, if I'm still holding the left mouse button here and I drag it onto this face, I can reverse that by hitting tab right away. So it's pretty much flipping the tool, right? So I drag it on this face, and as long as I'm holding the cursor still before I let go of the cursor to drop it, you can press tab to pretty much do this functionality right there. Okay, so we'll go ahead and make this 0. Actually, you want that to be 180. There we go. All right, we'll switch to our positions tab, and again, we'll dimension this here from this edge. Make that 25, and then 10 from this edge here. All right, so there's one locking tab. We definitely want to insert more of these, but instead of dragging and dropping those, repositioning all of them with dimensions, we have one here. We like to be efficient in SOLIDWORKS, so we're going to go ahead and do a linear pattern of that specific feature along this edge. All right, so features and faces, let's use that feature there. Now that we see a preview, it's a little easier to see where you want these features to be patterned. Right, so we'll go ahead and hit the green check, and there's our locking tabs there, created pretty quickly using that linear pattern. Right, so again, we're leveraging some symmetry here. We created the indented grip on one side and these 3 locking tabs on one side as well. So again, we can mirror these features, and we'll go ahead and grab the right plane here. And instead of bodies, we can do features now. And we'll go ahead and grab those specific ones, including the mirrored, or sorry, pattern features as well. Hit the green check. There we are. All right. A couple more features here, and then we'll switch over and change gears. Okay. All right. So we're going to go ahead and do a fill pattern here on the side of this, and that's going to be for ventilation, right? So if we go here, you're not familiar with a fill pattern, it's a really great tool because you can go ahead and select a face that you want to create a kind of like a vent feature with, right? So it's just going to fill this pattern with a perforation, and you can have a feature created first if you want, and go ahead and choose that selected feature, or you can have SOLIDWORKS create that for you, right? So you can see based off the size and shape that you want to do, it'll go ahead and pretty much just try and fill in that boundary based off the parameters that you set here. So if I set this 6 millimeters, right, I can go ahead and change sizing here as well. It'll just go ahead and try to propagate all that here. You can offset the edge boundary there, right? So we can have that set at 12. And if there's any instances that you wanted to get rid of and not include in this pattern, you can go ahead and just toggle that deselection here as well. You can also use your selection tools and box select it also. So there is the fill pattern used to create that perforation there very quickly. All right, so just a few more things. I'm going to go ahead and skip the top vent here just for the sake of time. Let's go ahead and switch back to the top level assembly. Right, so here's the top level assembly now, right? And that is the sheet metal cover that we just created for this satellite receiver. Rotate that around here. You can see that the hems filled in that gap with this tab right there. All right, so we'll just go ahead and bring in the last component, and that's the bezel here. I can use mates to go ahead and position that here, but this was pretty much positioned where it needed to be when it was made, so I can just click the green check and it pretty much fixes it there in space. Right? So there is our finished satellite receiver there. Okay, so that was creating a part using the top-down modeling approach. Right? We started with an assembly. We created this this enclosure cover in context of the assembly. So you can go here, insert new part. That's pretty much how you create this blank part here. And then you can go ahead and use those sketch references to reference existing geometry there. So that way you get that external reference to this geometry. So if anything changes or moves or gets larger, this will update with it as well, right? So that's the external reference that you can create using that in context editing method. All right. So let me just switch back to that specific one. Right. So you created this sheet metal part. You want to go ahead and export this as a DXF or create a 2D drawing. When you create a 2D drawing for this, you might be thinking, okay, so this is in its folded state. You might want to create a configuration for the flattened state. You don't need to do that because what SOLIDWORKS is going to do the moment you create a drawing is create that that flattened configuration for you. So when we go here, creating drawings for sheet metal parts works the same way as you would with a regular drawing for parts and assemblies, right? So when it does take a little bit of while to calculate because it's going through and creating that flat pattern, right? So it's going to go ahead and update that, and when you switch to the drawing, you can see that the view palette automatically populates with a flat pattern as well, and all the other standard views, standard orthographic views that you would use as well, right? Front, top, isometric. So you can go ahead and do that bring in any of these views and go ahead and detail them with annotations and all those dimensions however you see fit. I'm just going to go ahead and bring in this flat pattern here just to show a few things with that flat pattern. All right, let me go ahead and set the scale to be a little bit larger so you can see a few things. All right, so with the flat pattern, a couple different things that you'll see here is some of the bend notes for the bend lines, bend up, down, right, and the bend radius value with also the angle that you bend it, right? So if you right-click on this drawing view, you can click on properties and hide all those. You can choose to hide the bend notes. If you want to see the bounding box, you can go ahead and check that box right there. And then you can go ahead and dimension this and annotate it however you see fit. Yep, so that's it for sheet metal drawings. If I switch back to the part itself, you can also right-click on the body and hit flatten. It's the same thing as doing this sheet metal flatten up here. You can kind of see this in its own flattened state as well. Right, there you go. And again, something to note is that the formed features don't get flattened. Right, you can see some of the bend lines, the bounding box, so on and so forth. And you can change how that looks when you right-click and edit the feature. You can choose how you want that to show in that flattened state. One cool thing that I think is beneficial when you're kind of creating your sheet metal parts is you can actually do this toggle flat display while you're working with your model, and it'll kind of show in yellow the flattened state of your material with the formed piece or the folded in its folded state. Right, to get out of this mode, you can just click anywhere in the graphics area, and that's the toggle flat display. All right, so you can also right-click and export to DXF, save as DXF, enclosure cover. Go ahead and hit save. You can select sheet metal here and bring in the geometry. If you want the bend lines or anything, you can go ahead and select that there as well. Right? Single file, if this is a multi-body part, you can choose single file and it'll have multiple sheets for that DXF file, or have them broken out to separate files here as well. Go ahead and hit the green check. And then you can save as DXF and it'll create that DXF file. Okay, save one more time. And that DXF file was created. You can go ahead and shoot that file over to your machine. Go ahead and cut this part out, your water, your laser, however you're cutting that material out. All right, so that is creating that sheet metal enclosure cover there in SOLIDWORKS, and creating this drawing as well. Okay, and the top level assembly here. All right, so the other method that I want to show you is that convert. Let me see, Alt-Tab. What happened to my PowerPoint? The convert to sheet metal, right? So we'll talk about the convert to sheet metal, how that works in SOLIDWORKS. So if I open up an assembly here, right, I'll just cover this very briefly. So this is very easy to do when you're trying to create some complex sheet metal enclosures or covers or guards for some assemblies here. Right, if I go ahead and just hide this component, we have this assembly we want to create a sheet metal cover for, right? So what you can do is create this solid geometry using just regular SOLIDWORKS features, right? Just a bunch of extrudes to pretty much create a region where you want to pretty much create that cover. Now, when I open this part, I can convert this solid body into a sheet metal part very quickly by using this convert to sheet metal. So this convert to sheet metal, you can use a gauge table here as well. right? Let me see. Convert to sheet metal, metric. And right here, when you hover over it, it says select the fixed entity. So this is going to be the fixed face right there. 10, let's go to, maybe that's the wrong gauge table, but this will do right here. Select the fixed face right there. And then you can go here and choose the bend radius values for each of those. And then right here in this box right here, when you select an edge, that's going to pretty much create a bend wherever you select it. Right? So if I grab any of these edges here, it's inserting those bends to pretty much wrap a piece of sheet metal around that body. So this body right, or this checkbox right here to keep body, when I click OK, it keeps that solid body, and I can hit tab to hide that. And you can go around here and just keep selecting additional edges to cover that solid body there, right? So I can go to convert to solid, edit to feature again, and continue adding additional edges here. So I'll go ahead and select this edge here. You can see it automatically creates that rip where it needs to. Right. Go and we'll do one more on this opposite side here. And coming down just like that. All right, we'll hit the green check. And since I'm using a pretty thick material here, it's probably having some issues in these tighter regions, but you can see how that works there. Let me go ahead and try and change this here. Let's see. Yeah, it's having issues based off the gauge and the radius values in these specific regions. But that's pretty much how it works. You can do that very quickly and adjust those parameters however you see fit to create that kind of sheet metal enclosure or a guard or cover for things very quickly by just, again, starting with a solid body, and then you're pretty much wrapping a piece of sheet metal around it, selecting the edges to create those bends like that. Okay. All right. So that sums up the webinar here, and that's sheet metal design in SOLIDWORKS. We covered pretty much an overview of the sheet metal functionality in SOLIDWORKS, talking about the specific features that get created in the part, in the feature tree. Okay, showed how to do some top-down design with some in-context references, see some external geometry there, and the convert to sheet metal